Okay, so hopefully by now you've purchased your Arduino. I actually have two here. We'll go ahead and just do a quick primer on the things you need to know about your Arduino. First off, they can be powered in two different ways, either via the standard DC power jack, which you got here and here, or via USB, which is here or here. They generally come with your standard USB cables. This one here is the Uno, and this one is the Mega. We'll be doing most of our powering for now while we're programming it based off the USB. So, sorry about that. So you don't have to worry about getting a power break yet. I'll be using the Mega for most of this tutorial, but it transfers directly over to the Uno. What you'll see here basically is a little reset button. It just resets the whole board. I don't actually use this reset button. There's a way you can wire up this first pin reset here to a button that just shorts it to ground. As soon as you do that, it resets it. Also along here you have your 3.3 volt, your 5 volt, 2 grounds, and a VIN, analog inputs or outputs. Actually, sorry, these are analog inputs. Digital in or out, communication, and pulse width modulation, which are basically digital ports that you can do PWM on. The Uno is roughly the same. You got your reset button, your same power header pins here, less analog in pins, and then all these digital up here. So yeah, that's basically it. Important things to note: don't put them on metal when they're powered on. The solder and traces go all the way through. So yeah, you don't want to short it out. So that's the Arduinos. I'll just go ahead and move this guy out of the way. The next thing that hopefully you already have is a breadboard. So either like this one or this one. Many different options. I'm going to be using the small one for now. Important things to note about this: you'll notice that there's a positive and negative indication on these two breakout power boards. If you plug negative into any of these pins, this whole bar becomes a negative. So let's say I take a lead here and just plug it in this one. Everything along this, in this one column, becomes negative. Same thing with positive. I plug into this positive, that bar becomes positive. Now, it does not energize this bar magically. You can run a jumper, say from one of these pins over to this positive, and then that will do that to this one. Same thing with the negative, you can jumper over. So that's how that works. The rest of this grid, not looking at the power bars, is you'll see this this array here, which I don't think I can zoom in on very well because this is not my good camera. Anyway, they're numbered top to bottom from 1 to 30 in this case, and then alphabetically A, B, C, D, E, and there's a break, and then F, G, H, I, J. If I were to plug in something into 1A, then 1B, 1C, 1D, 1E all have continuity. These go horizontally in rows. However, the break does break something. So I can have something over here on this side and something over here on this side. This is as if it's two separate boards. This is actually a divider. And they really have that so you can do some integrated circuit pieces across them, which we'll get to later. An example of that would be like one of these. If he was out, I can be able to put them across and then be able to put stuff to different pins. If I put them over here, it won't work. So that's the reasoning behind that. Back on there. Okay, so that's the really quick primer there. The next thing you need to know is this guy. This is your DS 1820 or 18B20, which is a Dallas Semiconductor. 18B20 is just the model number of this temperature sensor. It's going to have 3 pins, a little half-cylinder package, a little flat face there. So basically you have a positive, a signal, and a ground. You can use this for like ambient room temperature, hood temperature, stand temperature, things like that. Obviously, you don't want to just stick this in water because, well, exposed metal and all, it's probably a bad idea. I was just using this to show you that that's what it looks like. You can actually get them like this and put them in your hood or buy your LEDs or something similar. But for in the tank, I really hope you purchased a waterproof one, which looks like this. So basically, that's in this package, stainless steel, heat shrinked, a long cable, and at the end of it, 3 wires, which again, red, positive, black, negative, yellow signal. So what we'll go ahead and do is we'll go and get started here. I will go ahead and take the red and plug it into 1E here. You have to bear with me just a little bit. There's been a lot of plugging and unplugging of these wires, so try not to break them. I'll put the yellow signal wire into 3E, and lastly the ground into 5E. So basically every other one in the E column there, like so. Yeah. Now the next thing you need is a resistor. And this is actually what they call a pull-up resistor. It goes between the signal line and 5-volt positive to pull up the signal. Now, your resistors come like this. This is a 4.7K ohm resistor. I believe this one's half watt. You can use quarter watt, 8 watt. It really doesn't matter in this case because it is just a pull-up resistor. Now, what you need to do is basically get that between the positive and the signal. So we basically bend that like so and go, and for this case I'll just put it in C. So I'll put it in 1C to 3C and get it in there, and there you go. Now as you can see, that kind of sticks out kind of far. It's kind of ugly. It kind of is going to get in the way. It's easily bumped and whatever. So I actually don't bend mine like this. I bend mine a little differently, like so. And the reason for that is because now if I want to go between C1 and C3, there it is. It's nice, it's kind of low, looks a lot better, it's not really in the way. That's pretty much it. So yeah, so now we've got it wired up to the board. That's really all that takes. Now we need to be able to get the signal to the Arduino. So what we'll do is, there's a few ways to do this. We could go straight from the 5-volt on the Arduino to anywhere in that 1A, we'll just go 1A, and that would get us positive. Now, and the same thing for the ground. We could put the ground in either of the 2 ground pins for the Arduino and put it in, 5A. That would get us power, positive and negative. And I'm a little bit of a DC purist, so I'm, using red and black. The problem with this is you only have 2 grounds on your Arduino. That easily uses up your grounds when you go to add, like, say, a LED, motor, whatever. So this is actually not how we're going to do it. What we're going to do is take this, obviously, to that power bar on both of them. Actually, I'm going to put them down here on the bottom so don't get the 2 confused. So, sorry about that. Okay, so now we have black to negative, red to positive, but now we need to get them over to the actual items, the actual probe here. So we'll run a ground, jumpering it over, and then a positive, jumpering it over. So I'm going from the positive bar to 1A, and the negative bar to 5A. So, like so. And you can bend those out of the way, it doesn't really matter. Then what I'm going to do is get a different color, something we can see. We'll go with a blue. And I will take this one, and we need to get our signal now from the temperature probe to the Arduino. So I'm going to put that in 3A because we're going across that 3 column, or the 3 row to get to the signal wire. And then we just need to pick a digital input. I'm going to I'll go with 2. Right there. So, that is how you wire it up. Now, since we have it wired, we need to go do some programming. It's not really programming, we just need to go write a sketch, as they say. So I'm assuming by now you've already downloaded the Arduino software and connected your Arduino. If not, you can message me if you have any problems doing so. Otherwise, it's pretty straightforward. There are some issues in Windows 8 where you'll have to get around driver signing. If you do have the Uno, you do need to actually install drivers. If you have the Mega, you shouldn't have to install drivers. Anyway, so let's go ahead and get started with the sketch.